Now we're going to start talking about what we call slope, right? Slope, you guys imagine the slope is the inclination of a mountain, right? And how fast something is going up or down. So that is basically what we call slope. So looking at a graph, it says find the slope of each line. Now, it will be nice if I had 2 points on the graph. Now, I'm going to just graph 2 points. I could have choices. Sometimes I have choices. I'm going to use a point where I could see the coordinates. Like if I wanted to find the coordinates, first let me start with the wrong point, okay? Let me write down a wrong point. Now, this point is wrong. I can see the x value, right? If I was to do this, I could see the x value, but what about the y value? Not necessarily, right? That's not a good point. Now, so the points that I can use are points where I can see the x value and the y value. Now, my choices, I could choose this point. You guys see the x value. I could find the x value is -4. I could find the y value is -1. So that's a good point. Another good point will be this one. You guys can see the x value is +1, the y value is +2. So I need 2 points. Now that I have the 2 points, my slope, my inclination is basically like giving directions from one point to the other. Now, I never said which one to start from. I just said from one point to the other. I'm going to use a fraction. My top of my fraction is going to be rise. So how many spaces do you go up or down, right? Positive if it goes up, negative if it goes down. So my number on the top of my fraction is going to be the rise, again, up or down. And then the number at the value of my fraction, we usually call that one the run. That do you run to the right or do you run to the left? Positive if it's to the right, negative if it is to the left. Let's say I'm starting from my point that is farthest left, okay? Let's say I do that. I'm gonna go up 3, right? You guys can count the squares, 1, 2, 3. So I go up 3, so I'm gonna say +3 on top. Remember, the rise is how much did you go up or down? Positive if you go up, negative if you go down. Again, I'm looking at directions from one point to the other. Now, my other direction, so first I'm going up 3. And then it seems like I need to go to the right. I'm going to count my squares. 1, 2, 3, 4, 5. So my directions, I go 5 to the right. So let me put a 5 at the bottom. Now, +5 because I go to the right. Negative if I go to the left. So my slope in this case would be 3/5. That's it. Simplify the fraction if you can. In this case, I cannot. And what I mean simplify is divide both numbers by the same value. So dividing by 2, dividing by 3, dividing by a value that makes my number smaller. Right? I'm going to avoid decimals. But if I can make my number smaller, then I would simplify. Now, some of you might be like, what if I wanted to start from the other point? Okay, not from the one on the far left, but on the one on the far right. In this case, you would have gone down 3. So as a matter of fact, let me even say a -3 because you go down. All right, so -3 over, and then you have to travel to the left 5 spaces. So let me call this -5 because you travel to the left. Interesting part is in division, right? A fraction is division. Two negative signs become a positive sign. So my answer becomes +3/5. I get the same thing. So it doesn't matter on which point you start from. If my numbers are both positive, then my fraction is positive. If my values, both of them are negative, the negative signs will cancel out. So my answer will still be positive. Now, if one of my values is negative, it doesn't matter if the negative value is the top numbered or the bottom numbered. I just said one of my values is negative, bring the negative sign to the front. Okay, so what do I mean with that? Imagine you had a number like positive 2 over negative 7. This will become the negative sign in front of the function, and I'm just going to write 2 over 7. So if there's a negative sign, bring it to the front. All right, let's take a look at question number 6. Let me get a point. Well, let me get 2 points. Choices that I have are this point, this point, this point, this one, and this one. I'm going to choose a point where I can see the X and the Y value. I only need 2 points, right? There's more than 2. You only need 2. So just to pick 2, I'm going to pick this one and this one. It doesn't matter which 2, right? I'm just going to pick those 2 values. All right, so I have to travel from one point to the other. First of all, I have to think of, do I go up or down? I'm going to start traveling from the point on the far left. From the 2 that I chose, the one that is on the left. And it seems like I have to go down 6 spaces. So I'm going to call this a -6 because I went down, right? You count how many squares. We go down. And then I'm going to go to the right 3 spaces. Positive because I go to the right. So my slope right now is going to be -6 over 3. Now there's a negative sign. So now this thing is going to become negative in my fraction 6 over 3. Okay, so bring the negative sign to the front. It doesn't matter if the negative sign was on the top or the bottom. Now, each of my numbers, I can divide them by 3. Right, I can go 6 divided by 3, and I can go 3 divided by 3. So this is going to simplify. Let me do my arrow. So it's going to simplify to -2 over 1, right? 6 divided by 3 is 2. 3 divided by 3 is 1. Now, interesting, when my fraction is over 1, so when there's a 1 at the bottom, it stops being a fraction anymore, right? It's not a fraction anymore. It stops being a fraction. So it's not -2 over 1. Let me write this as -2, right? When there's a 1 at the bottom, right? You guys could have seen it from the beginning. Oh yeah, 6 divided by 3. Yeah, that was 2. When I have a fraction and there's a 1 at the bottom, stops being a fraction. Okay. Now, one thing, if you guys notice, I want us to see something. The way we read the graphs, let me highlight my graphs. This one going here and this one going here. Right. Every time we read words, right, when there's a letter, we're reading a book or something, we tend to go from left to right, right? We read words from left to right. So same thing with our graphs. See them from left to right. When the graph is going up, like our question number 5, look, my slope happens to be positive because my graph is going up. When my graph is going down, question number 6, look, my slope happens to be negative. Again, traveling from left to right. Another thing I want us to practice for slopes is in word problems. Now, the slope is the number that keeps on happening. Like how many times? There's a number that's going to happen multiple times. How many times does it repeat? Right? We usually call it in math, sometimes we call it unit rate. But it's just that there's a number that's going to keep on repeating. So let's see here. Pranav rented a bike from Ming's Bikes. It costs $18 plus $5 per hour. So if I was looking at here and I said, okay, this person pays $18 and then $5 per hour, right? So I will have to go $5 for the first hour plus $5 for the second hour plus $5 for the third hour. So you see how there's a number that keeps on repeating. I want to know how many times does it repeat in general. So here it says, at the end, this person is going to pay $33, right? If Pranav paid $33, then he rented the bike for how many hours? Key here, how many hours? That's telling you, like, hours is the one that's repeating. I want to know how much. How many times is 5 repeat? So far, what I have here, have 18 plus 5 is 23, plus 5 is 28, plus 5 is 33. Okay, so I'm going to stop here. This thing already adds up to 33. Right, to write this even better, I'm just going to write 18 plus 3 times 5 is equal to 33. Right, 5 was the number that kept on repeating. I wrote a 3 in the front because it's how many times did 5 repeat? That numbered, that's my slope. So here, what is the value of the slope? In this case, 3. Again, for slope is that there's a number that's going to keep on repeating. I want to know how many times does it repeat? And that's what we call slope. Okay, here, a wise man once said, 200 reduced by twice my age is 8. Okay, so let's read this real quick. 200 minus twice my age. So I can just say it minus 2 times the age. I'm going to call A for age. So 2 times the age is equal to 8. Right? Some people might say, well, 200 minus A is equal to 8 because the age twice. I don't know what the age of this wise man is. It even says what is his age. But so I don't know his age, so I'm just gonna use the letter A. In mathematics, when we don't know the value of something, we replace it with the letter. So notice how age is the number that keeps on repeating. How many times did this number repeat? Let me highlight this function here. A repeated -2 times. So my instructions here on the top, I'm not solving for the man's age. I'm solving for what is the value of the slope. In this case, my slope is -2. How many times did this repeat? -2. Big thing I want us to emphasize here. The slope happened when there was a multiplication, right? Look, 3 times 5. -2 times A. We're going to talk a little bit more about slopes next week, but slope happens in a multiplication. Remember, multiplication, you guys talk in elementary, kindergarten, or first grade, that multiplication was repeated addition or repeated subtraction. Okay, that's what we did for today. Let me zoom out so you guys can see it.